The viewers, today we discuss the interesting property of Laplace transform is called asymptotic properties. Properties of Laplace transform. Actually, what the property is? If GS is the Laplace transform of GT. S is the complex parameter of the Laplace transform which maintain all Dirichlet condition in any finite interval t and is of exponential order of e to the power at at t tends to infinity, then number one condition is limit s tends to infinity g of s equals to 0, and the second condition is limit s tending to infinity s gs, that will be g0, and this condition is known as initial value theorem. But first we have to prove it. Number one conditions. Here GP, we write the definition of the Laplace transform from the definition 0 to infinity GT e to the power minus st dt. Now since GT is a bounded function, so there exists the constant, suppose there exists the constant n such that mod of GT is less than equals to n e to the power at, since it is the exponential order of e to the power at. Therefore mod of GS, that will be less than equals to 0 to infinity mod of GT into mod of, actually since it is a complex parameter, so it can be written in the form of x plus iy into t dt, where s can be written as x plus iy. So clearly there is a bounded function n into 0 to infinity and it is e to the power at, so we can include it, and mod of e to the power it minus it is equal to 1, so it will be x minus at dt, that will be equals to n by x minus a, and it's obviously clear this 0 minus of this, and it will be for 1. That's why these things happen, for the result is valid for x greater than a. Since x greater than a, so this term quantity will be positive, that's why negative term, and if we after taking after integration, it will be 0 to the power minus infinity tends to 0, that's why condition is x greater than a. And clearly if we take the real valued function real way, this path is real path, then it tends to 0 as x tends to infinity, so we here take the real path, and x tends to infinity, that means this quantity tends to 0, hence we can say as gs tends to 0 as x tends to infinity, and if we are taking the real path, but so the condition is, if we take the real part of P, then we have x tends to infinity implies P tends to infinity. So we can say limit P tends to infinity, sorry, here we can put S, parameter will be S, and actually because we are earlier stage, we take the parameter, complex parameter of the Laplace transform F, that's why anyone can take the complex parameter P, whatever may be. So this implies S tends to infinity, that means limit S tends to infinity g of S, that will be, what will it takes as 0, limiting form is 0. Now with conclusions, that's as ensures the first part of the theorem. Next stage we are going for the second part. This is called the initial value theorem. Now suppose for the part 2, GT is piecewise continuous, that means maintain or Dirichlet conditions, and GT maintains all Dirichlet condition and in any finite interval of t and is of exponential order of e to the power at at t tends to infinity. Then we have from the definition of Laplace transform of derivative of function L of g dash t, that will be S L of gt minus g0. Now from the first part of the theorem, in the earlier stage, using the conditions 1, it's clear g dash t, since gt maintains all the conditions, so we can conclude g dash t maintains all the conditions. Here it is g dash t maintain all the Dirichlet conditions in any finite interval of t and is the exponential order of e to the power at. Since gt is so, that's why g dash t maintains all the conditions. So clearly from the first part of the theorem, L of g dash t is equal to 0. So what happens there using these conditions? L of g dash t equals to L of gt minus g0 equals to 0, which imply SL of gt, that will be g0. We are using the condition limit as s tends to infinity. Here also limit s tends to infinity SL gt is equal to g0, and we have proved the second part, and this theorem is called final value theorem. Sorry, this is an initial value theorem, and it is an interesting property called asymptotic properties of Laplace transform. Now in the next classes we will study another interesting property called final value theorem. Now today we end our class. Thank you.